Hello and welcome back. In this video, we're going to go over some of the main points of Chapter 9, Advanced Modularization Techniques. In previous chapters, we've worked with what we've called modules, such as the housekeeping module, detail loop, and end of job. And we're working with that same concept again, but we're referring to these modules as methods. Method is another name for a programming module that carries out a certain task. So for example, in previous programs that we've seen, we saw housekeeping perform the task of getting things ready for the program. Anything that may be done, such as printing out labels at the top of a report before the main report was printed, was a method. So we're switching up terminology a little bit. We're going to call this a method. And as we've seen before, and we're going to see again, once a method is created, we can call that method from another method, such as main, or another program. We can also call that invoking the method. Now, once you create a method, you can call it as many times as you want. That's actually one of the advantages of modularizing your program, is making your code reusable. A calling programmer method is called the method's client. So technically, if main calls housekeeping, main is the client in this case. So in order to use a method, you must first define that method. And the definition of the method includes a method header. Technically, that's called the declaration or definition of the method rather. And a header has some information about it, such as its name, if it receives any information, and we'll talk about that later. And then after the method header is the method body, and these are the actual statements inside the method that carry out the task. Some folks call that the implementation of the method. And finally, a method has some sort of return statement that returns back to the calling body of code, the calling method. So I'm going to pause here and just remind us that this chapter is in the context of the programming logic book, which uses pseudocode. So we're going to see these concepts fleshed out using pseudocode. And they are consistent across various programming languages. For example, C#, Java, Visual Basic use all of these concepts. However, the implementation of those concepts, the actual syntax, is a little different from one programming language to the next. However, all the main concepts are the same. So in our conversation that we're going to have, we're going to see, we're going to revisit the concept of variables and constants. And if variables or constants are declared inside of a method, we say that they're local to that method. And if they are global, that means instead of just being available to one method, they're available to all of them. So let's take a look at a simple example. This particular program calculates an individual's weight on the moon. So we basically get started by asking the user to enter their weight in pounds, and we take that weight and we convert it to a moon weight and then output the equivalent moon weight. So very simple program. And technically this program is pretty small. It could all be written in main. But since we want to illustrate how we can break this up into a main method as well as a second method, we're going to take a look at this. Now in particular, we want to be able to support both English and Spanish as our prompt to ask the user for weight. So we're going to ask them to type 1 for English and 2 for Espanol. And based on the language code that the user types, we will either output the prompt, please enter your weight in pounds in English, but if they type that it is a number 2, they speak Spanish, we'll give them the alternate prompt in Spanish. So all of that logic could have been inside of main. But if you look at how this solution is divided up, we have a main flow here, and over here we have a method called display instructions. So the method name is up here as well as parentheses indicating this is a method. Note the return statement at the end would return us back to whoever called this method, which we'll see as main. And the steps in between basically indicate what this method does. It declares some variables. It has a variable here. It has 2 constants that represent the prompt we would want to give the user for English, please enter your weight in pounds, as well as the prompt for Spanish. And then the steps ask the user, are you an English or a Spanish speaker? And we input that code. If they said English by typing language code of 1, we give them the English prompt, else we give them the Spanish prompt. So at this point, we only have language support for the 2 languages. And then we return back. One thing I want to point out is this method has its own declaration block. So these variables and constants are local to display instructions, meaning that display instructions can use them, it knows about them, but other methods in this same program, such as main, do not know about and cannot use these variables and constants. So display instructions has to be declared before it can be utilized. Here in main, we see it being used after we've declared a few variables at the point where we want to display the instructions to the user and get the language code. Get the language code and then display the appropriate instructions. So we see that call right here represented by the rectangular box with the line at the cross. This is a method call. And notice to call the method, we just use the name of the defined method. It must match up and the parentheses. After that point, we can proceed with the rest of the program. The rest of the program asks the user for their weight. It takes that weight times 0.166 to calculate the moon weight, and then it outputs the answer. So that's the flow chart. Pseudocode is the same down here. Notice this is the main flow. We call display instructions here when we want to execute those steps to prompt the user, get the language code, and then prompt them in their language of choice. And then we continue on. It's important to know that when we call display instructions, all execution of main pauses and waits for display instructions. So at this point here where this is called, it literally jumps down here. The program executes all of display instructions and returns back up to its caller. Main then resumes with inputting the weight and so forth. So that's an example of a program that utilizes a method. So in that particular example, it became clear that when you call a method from a program, you have to know what the method does. Well, that just makes sense. You wouldn't call it if you didn't know what it did. You have to know the name of it. You have to know if there's information to send to the method, because sometimes we want to pass data into a method. Now, if you look back at that example, when we called display instructions from main, the parentheses here were empty. Had we had data to pass to display instructions, we would have had a value in between the parentheses here. So that's the kind of thing you would need to know. Does display instructions receive data? So in order to use it, we would have had to have known that display instructions as defined over here does not receive data. In other words, no parameters. We'll see that term again shortly. So that's the kind of information you need to know about a method in order to use it. And then finally, does the method return anything back to its caller? Again, In the last example, it didn't pass any data back to main. So let's talk a bit about passing data from one method to another. So there are times where we'll need to share information. And when that's the case, we'll want to pass an argument to a method. Argument is just a term for data that we're passing. In order for a method to receive the data item, it has to define what's called a parameter. A parameter, it's basically just like a variable for that method, but it's a special variable that receives a value from its caller. And when a method receives a parameter and we want it to be able to function in that manner, we must provide a parameter list that indicates what is the type of the parameter and what is its name. And that'll make a lot more sense once we see an example of this. This chapter is extremely famous for throwing a lot of terminology at us. So we have to be patient with all these new terms. Here is another new term, signature. Signature refers collectively to a method's name and parameter list. In other words, what's its name and what kind of data is it going to be receiving? So let's revisit the moon weight program for a moment and look at some of the limitations of it. I'm actually going to bounce back over here for a moment. If you notice, the program begins, we call display instructions, which asks for a language preference and then prompts in the appropriate language. We return back to weight. But when we output your weight on the moon would be, we're actually always using English, regardless of whether or not the user indicated that they're an English speaker. So the next revisitation of this program tries to handle that particular problem. There are several approaches to it. The one that we're going to take is to store the variable that holds the language code in the main program and then pass that data to a second method. So let's take a look here. We still have our main flow and we still have our display instructions. But notice that main, we've moved some of the steps from display instructions to main. We're going to use main to ask the user, what language do you speak? 1 for English or 2 for Espanol, and we read that in. We did that so we could have the code available to us later in main, such as down here, when we wanted to output the answer your weight on the moon would be, or the equivalent Spanish output. So now, because we've used main to collect the code and store it in the local variable of main called code, we could then refer to it when we needed it later in the program to output the appropriate weight on the moon. The problem is display instructions, which of course actually displays the instructions, please enter your weight in pounds or the equivalent Spanish, needs to know what that language code was. So here we're finally seeing the use of what's called a parameter. So let's look over here at display instructions for a moment. If we want display instructions to receive data, instead of using empty parentheses, which would indicate no parameters, we define a parameter called lang code. And just as you've named variables in the past, and we've talked about the fact that you choose the names of your variables, you can use any name you want for the most part, as long as it complies with the rules. You don't want to start a variable with a number, it should be a letter. Always make sure there's no spaces in the name, that kind of thing. Other than that, you can name your parameter anything you want. Lang code then is going to be available throughout the program. Notice it's being referenced down here. We also need to define what type of data lang code is. So we're saying that we have one parameter that's a numeric type called lang code. So in addition to being able to be used as a variable throughout our program, parameters are special because they're also going to receive information from whichever method called display instructions. So going back to main for a moment, remember that main has just finished asking the user for code and reading it in. We get to the point where we call display instructions. This blue flow line is showing us that the control is going to shift from main. We're going to jump over to display instructions and execute that. But it also shows us how we can pass data into lang code, into that parameter. To pass data to a parameter, we indicate in between parentheses the argument that we want to pass in. So that's a formal term. Argument refers to the data to be passed into the parameter. And in our case, it's the code. We just read the information from the user. They typed 1 or 2. We stored it in code. So therefore, code is what we're going to pass to this lang code parameter. It's important to realize it's actually the value that's being passed. So for example, if the user typed 1 for English, 1 is what's going to be passed into lang code. And for the remainder of display instructions, we will not refer to that value as code, because code is not defined in display instructions, it's defined in main, but we will refer to it as lang code. So here we check if it is 1. In this case, if they had typed 1, this would be true. We'll go ahead and output the English prompt. Here we see the same thing. This is our main flow. Here we're calling display instructions, passing an argument of code. This would invoke display instructions, so the flow of control would jump down to display instructions, and we would execute this body of code. The return statement returns us back to main to resume where we left off by beginning the next step, which is to input the weight. Here's another example of using a parameter. This one isn't as functional as the last, to be honest with you. It's really just an example that shows how arguments and parameters work with a little more detail. We have a main method as well as a my method. So we're really being rather generic at this point. We just called it my method. My method has one parameter of numeric type called myVal. It receives a value, it indicates what that value is, and then it adds 86 to that value and outputs it. Extremely simple. Receives a value, adds 86, outputs it. So let's see how main is using this. Main starts out by declaring a local variable myVal and sets it to 18 and displays that value. Then things get interesting. We call my method and we pass the value of the variable myVal. This is called an argument, and as we know, myVal is 18. So 18 is the argument that gets passed into myVal, the parameter. I got to pause right there and say that can be a bit confusing. We have a variable in main called myVal, which we're using as an argument, and we have a parameter for my method called myVal. Is that a problem? It's not a problem. An argument and a parameter can have the same name, Or, as in the last example with the moon weight, they can have different names, and that also doesn't create a problem. Because what happens is, remember, when we call my method here, it's really whatever the value of this variable is. My val is 18, so 18 is then passed into my method, and we already viewed what that does. It outputs it, adds 86, outputs it again, returns back, and then main finally outputs my val again. Seems kind of strange that we're doing all this. Why are we doing it? Let's take a look at the output. At the beginning, main has a value of my val of 18. Then my method is called, and my method is displaying a value of 18 for its copy of my val, which is a different memory location than my val, the variable of main. At the end of my method, my val is 104. No surprise there. Remember, my method added 86 to my val. This may or may not be a surprise to you. At the very end of the output of this program, this last line here is coming from main, and it says at the end my val is 18. And that's because they're driving home the point that main has its own copy of variables, regardless of the fact that my val is the same identifier name in both main as well as my method's parameter, my val. They are two separate memory locations. So 18 is passed from main to my method, but when my val in my method was updated, it did not affect the memory location of the variable in main. So that's what they're just trying to get across. When when we do a pass by value, that's called, just understand that it is the value that is passed in, but a separate memory location is maintained in the second method. So that was both that and the moon example illustrated methods that require one parameter. Methods can require more than one parameter. We'll just have a list of them, each with their own data type, and we'll separate them with a comma. And then when we call that method from the client, we'll pass more than one argument. The important thing to understand is the number of arguments must match the number of parameters, as well as the data types must match up. So let's take an example at a simple program that prompts the user for balance and rate, and based on the balance and rate computes a tax by taking the two values multiplied together and outputting it. So again, this could have all been done in main, but we decided to write a separate method called compute tax that actually does the computation and displays the answer. So main is very simple. We have two local variables, balance and rate, which we use to get the values from the user. Now they're oversimplifying a bit here. We would need a prompting statement that says enter balance before we actually input it, as well as rate. But we can imagine here we're getting both the balance and rate. We wanted to be able to pass balance and rate to compute tax. So you can see we have two different arguments here. One, the balance that the user entered, and the second, the rate that the user entered. Now for this to work correctly, on the defining side of compute tax, we must have an equivalent, we must have a method where the parameter list matches up to the argument list. So the argument list is two numbers. So therefore the parameters over here, we must have two, and they both must be numbers, which they are. Notice the name of the parameters, amount and rate, don't exactly match up to the argument names, balance, rate. One matched, one didn't. Again, it doesn't matter because the values are passed positionally. whatever is in the first position of the argument list will be passed into the first parameter value. So if the balance is $100, then $100 is what's passed in for the amount, and compute tax will now have a value for amount that it uses throughout the method. And the same would apply for rate. So you can see positionally these values are passed. Compute tax then is able to compute the tax based on amount and rate. And notice it does not refer to it as balance. Balance is not defined in compute tax. It refers to it as amount. And finally, it outputs it. So we have the same thing down here written in pseudocode where we have two arguments. I do want to point out in your argument list, you never list the data types, just the values that you're passing. It is in the definition of the method where we have the parameter list, and that does include the data types. So a couple things when you're using a method such as compute tax, once the method ends, any variables, parameters for that method cease to exist. So they go out of scope and they are not retained. So if we go back to that example for a second, now this particular example calculates tax and it outputs it for the user and it calls it a day. But if we wanted to not output the tax here, but instead retain that information, we would want to change our method to return tax. And that is possible to return a value back to the calling method. We have to identify a return type for the method that indicates the type of data we're returning. In this case, that would be a num. If you have a method that doesn't return anything, such as the current implementation of compute tax, where we output the answer inside of compute tax and there's no need to pass anything back to main, then we specify what's called a void return type. It doesn't return anything. So how do we specify a return type? On the first line of the definition of a method, where it has the name of the method and then a parameter list if one exists, before the method name right here is where we indicate what type of data this method returns. So in this example, we don't see the implementation of get hours worked, but we can see that get hours worked is the name of the method, it has no parameters, and it returns a numeric value. Now the interesting thing about methods that return values are that they can be used in the calling program by either storing them in a variable or just directly using them. Here, if we imagine that this output line that we're looking at is in a main method, and this main method has access to a method called getHoursWorked that returns a numeric value, then main could output some text, hours worked is, followed by and concatenating to the numeric value that represents the hours worked. So in place of a number such as 40 that would be hard-coded, we could call get hours worked. This will go out to get hours worked, execute all the lines of that method, return back a value which is then output from main. So returned values are then used in a calling method. So let's take a look at that program and see all the moving pieces. This particular program has a variable for hours and gross, as well as a pay rate of $12. And the program wanted to get the number of hours worked that the user worked, and then from it calculate a gross pay and output it. Very simple. So we wanted to get the hours worked. Now again, we could have put those steps in main, but we wanted to define a separate method, and here you see it over here, to return the number of hours worked. So in this particular case, we were asking the user for those hours worked. So we didn't have a need to pass any data to this method. So notice the empty parameter list. We're not passing anything to it. However, get hours worked is going to return a number. So we have a return type here at the top of the method. So get hours worked defines a local variable work hours because we are going to prompt the user, how many hours did you work? Read it into that local variable. And here we see the change. Instead of just the word return, we indicate what it is returning. It is actually returning the value of work hours. So this method, because it has a return value then, with their blue line, the textbook is indicating that is passing a value back, which is then assigned to a variable hours defined in main. The reason why we wanted to assign it to hours is because the next step is to use it in the calculation. So hours equals is important. That has to be on the left side. We're kind of dipping down into two lines here just because we're running out of space. But this is an assignment statement that says set hours equal to whatever get hours worked returns. So get hours worked is evaluated first, returns a value such as 40, and then hours is set equal to 40. So that's how a return type works. Just a word of caution, it is encouraged to use a single return statement in a method instead of multiple return statements. This example shows a method called findLargest, which by the way has 3 numeric parameters. And it checks if first is larger than second and first is larger than third, then the first must be the largest, so we'll return it. So this actually returns whichever number is the largest. Else, is second bigger than the third? Okay, then the second must be the biggest, return second. Else, okay, the third's the biggest, return this. So here's what that would look like in pseudocode. In the various scenarios, we have these return methods. And actually, they did away with else's altogether because the interesting thing here is once you encounter a return statement, this will cause the method to cease execution, pass the value back to its caller, and ignore the rest of the lines of code. The thing about this is that it can be a little confusing. This is only, 6 lines of code, but if you get into larger programs where the method is much longer and you have various return statements sprinkled in here and there, then you have a second programmer that comes along and is supposed to modify that method. It is a much higher likelihood that they're going to introduce a logic error accidentally because not fully understanding all the various returns and what's going on. So a better approach would be to say, well, let's create a variable largest and we'll use a series of if statements. If first is in fact the largest, we'll set largest to first. Else if second is bigger than third, largest will be second. And finally, if neither of the other two are true, largest must be the third. So we set this local variable appropriately, and then we return that value back to the caller. It's much simpler in terms of return statements and much less likely to introduce problems. So to use a method, you have to know what the method does in general, but not necessarily how it carries out the tasks. You might be thinking, well, of course I know how it carries out the tasks. I wrote it. But keep in mind that a lot of the methods we use, we didn't necessarily write, and that's the power of modularization. For example, in Visual Basic, we use console.writeLine, which is a method that we know how to use, we know what it does, but we don't know how it does the write line. We don't understand all the individual steps that make that happen. Same with input box. We know its name. We know if it requires parameters. We know, actually, we do know input box has a return type of string, so it always returns a string. So I'm just using those Visual Basic examples because I know that they're familiar and we've used them. But it really applies to any programming language as well as pseudocode, that to use a method, you really just need to know its name, what data it should receive if it returns anything back to us. Just bear in mind, to use a method, it does incur a certain amount of overhead, which are the extra resources and time. So it does, when you call a method from another method, that it does incur a little bit of extra time, execution time in your program. However, most programmers would agree that this time is just very, very small, and it doesn't really matter too terribly much. You just don't want to get carried away with over modularizing your programs. But in general, it's a good thing to modularize. It makes your programs reusable. It makes them more reliable, because once you test a method once, you know that it works and you can use it all over the place.